Hello student. So we have done the electrostatic in the last lecture, right? So now we are going to start the next section, that is called electrodynamics, right? But we will start electrodynamics, right? Electrodynamics. So I hope you all know about the electrodynamics, because as I had discussed already in that section, like electromagnetism is divided into two parts. One is the electrostatics and what is the second one? Electrodynamics. We have just completed all the things related to electrostatics, right? Now we are just going to start the electrodynamics. Means what? We know the charge is in motion, right? Charge is in motion. When the charge is in motion, then the study of property or the effect of charge is called electrodynamics, right? So let's see. In this one, we are just taking the first section of this electrodynamics, that is current electricity. What's the first lecture? Current electricity. So when we are saying the current electricity, so how we are saying the current electricity? What is the meaning of current electricity? I know you all know previously something about the current electricity from your class 10th, right? There is a chapter that is electricity. So let's see. Let's start the chapter now. Let's see. So first thing that we have to discuss is called current electricity, right? First, what we will discuss over here, we will discuss current electricity. Current electricity. So if we have to discuss about the current electricity, then we need to understand what is the meaning of current, right? Because we know the general meaning of electricity, right? So let's see. When we are saying there are two terms, like one is the current and another is what? Another is electricity, right? So what is the meaning of current? Current is simply when it look like I said, there is a air current. I will explain you, don't worry. Air current, like we know there is a water current, water current. We can take any type of quantity, whatever you want. Like what is the meaning of this one? When there is a flow of quantity, right? When there is a flow of quantity, and from that we are taking the quantity passing through a particular cross-sectional area, right? If I am saying there is a lot of mains are running over here, right? If I am saying there is a lot of mains are running over here, and we have taken a very small area over here, right? So what number of mains are passing over here, we can say that is called mains current over here, right? That is called mains current. So basically when we are just dealing with the current, so current means it is a property, or we can say this is a directional property. When we are saying the current, then this is what? This is a directional property. It's a directional property. Direction matter for that. We cannot say, like if I am saying I am just standing over here, right, and there is a air flowing in this whole room, then what I can say? That is the air current? Not. There is a flow of air and we are just taking a particular cross-sectional area from that. Then air passing through this particular cross-sectional area is called air current. So same, when we are saying the current electricity, so what is the meaning of current electricity? The current electricity means we can say there is a flow of charge, right? So in general, how we are defining the current electricity? We are defining, it is defined as the rate of flow of charge through an area perpendicular to its flow. Its flow is known as electric current. Right? What is the meaning of this one? If in general I am saying there is a lot of charges are moving over there, right? There is not a single type of current. But when we are just taking any type of cross-sectional area in the flow of current, I mean in the flow of charge, then we can define the current over there, right? So let's see here. Current electricity is, in general, we can say it's we are taking as the first topic of electrodynamics, right? But when I am saying it's a first topic of electrodynamics, right? So it's a flow of charge. Charge can flow anywhere. It can move randomly, it can move in a oriented direction, it can move anywhere, right? So when we are saying the current, it means what? It's a directional flow of charge. Current means what? Current means simply we can say it's a directional flow of charge. So directional flow of charge, if there will be any type of directional flow of charge, that will be current. Like let's see here, if I am saying there is a lot of electrons are flowing in this, right? A lot of electrons are flowing along this direction. So we are not saying there is a current, right? But when I will take a particular cross-sectional area over here, then this electron will start crossing through this area. Then we will say there is a current in this, right? So how we define the current over here? It is defined as the rate of flow of charge, or in general, if I am saying this is the cross-sectional area we have, right? Through this cross-sectional area, if I am saying the delta Q current is passing, right? Delta Q charge is passing in delta T time. So what is the current is here? The current is delta Q by delta T. What is the current is here? The current is delta Q by delta T. This is called current is here. And we know if we are saying it's a directional flow of charge, so what type of quantity is this? Scalar, vector, tensor. It's a scalar quantity. In general, what we have to remember, it's a scalar quantity, right? You don't have to go right now with the tensor, but you can also just explain about some property like it is just matching with the tensor, but in reality what we have to remember, it's a scalar quantity, right? What is the SI unit of current? When we are saying there is a current, so the SI unit of current is ampere. What is the SI unit of current? It's the ampere, and it is represented by A. And you know there is a lot of unit we are using like milliampere, microampere, nanoampere. You can take whatever you want, right? Now let's see. This is the I we have, and if I am saying this is the current, so how we are representing the current? Either with the small I, either what we can say capital I. A small I, or what we can say capital I. If I am saying it's a directional flow, and what type of area we have to take? We have to take perpendicular area. Okay, so let's see here. If I am saying there is a area we have, then what we can comment on direction of flow of current. Direction of flow of current. What is the direction of flow of current? Direction of flow of current means we can say simply it is along the, what we can say, it's along the flow of positive charge. It's along the flow of positive charge. Either what we can say the opposite to the flow of negative charge. It is opposite to the flow of negative charge, right? Now let's see here. If I am saying it is along the flow of positive charge, either opposite to the flow of negative charge. So we also know one thing. What we know? If I am saying this is the point A we have, and this is the point B we have, right? Potential of this point is VA and potential of this point is VB. We have already discussed about the potential. If I am saying the VA is greater than VB, and we have just taken a positive charge over here, so where it will move? Can we say it will move from A to B? Why it will move from A to B? Because the positive charge is flows from higher potential to lower potential, because there is an electric field is acting on that, right? So we can say there is an electrostatic force is also here. So it will move from higher potential to lower potential. So we can also say this is moving higher to lower. So current is also from higher to lower. So what we can remember in general, we can say the current flows from higher potential to lower potential. Higher potential to what? Lower potential. Right. Now let's see. If we are saying there is a direction of current and there is a magnitude is also, why we are saying the current is a scalar quantity? If we are just dealing with the current over here, then what we will say, let's see here. If I am saying there is a current, so we can take a conductor over here. Now let's see. This is the conductor here. If I am saying the current is flowing along this direction, there is not any, it's a straight direction, and we can say this is the direction of current. But if I am saying the path of wire is look like this, this is the wire we have. It's not possible that we have always a straight wire. There is a curve wire we have. So in this one you can observe there is a curve wire, and in this curve wire the current is flowing along with the same, right? If the current is flowing along with the same, then what we will say over here, if current is a vector quantity, we are just assuming if the current is a vector quantity, so we have to explain with the help of vector. But you can see over here, when this is moving on this curve path, then no one vector explain the motion of this curve path, right? Any vector cannot explain the motion of curve. They are explaining the motion along a straight line. Like if I am saying this is the particle, this is the current I cap is here. So we can say this is the direction of current, right? But in this one this is changing, right? And even this is changing, so you know the result should be changes. Like when we are just adding the current, when we are just subtracting the current, the things should be changed, right? But the current is not following all those things. Or simply if we have to just verify, so we can say it does not follow the vector addition. It does not follow the vector addition, right? It does not follow the vector addition. That's why we are saying it's a scalar quantity. In general, I am just giving you some idea about this. If I am saying this is a junction we have, no? In this junction, this is, we can say the 2 ampere current is here. This is 4 ampere current is here, right? So what is the current is here? 6 ampere. What is the triangle law as we have discussed? We have discussed the 2 ampere, 4 ampere, 6 ampere. These are two smallest side. So 2 plus 4 should be greater than 6. Can we say is it correct? No. This one is not correct. So that's why it is not following the triangle law, or we can say vector addition. That's why this is what? A scalar quantity. Why we are saying it look like a tensor quantity? Because if you will change the direction of this 2 ampere, like I am saying just change the direction of this 2 ampere. When you will change the direction of this 2 ampere, then 6 will becomes 2. Because this is the 2 ampere is here and this is 4. 4 is coming over here, 2 is here. So can we say the remaining 2 will be moved over here? So when we are changing the direction of any one part, then the result will be changes. That's why we are saying it act like a scalar, it act like a tensor quantity. Okay? But what you have to remember, it is a scalar quantity. Okay? Now let's see here. If I am saying there is a cross-sectional area we have and there is a flow of charge, right? This is the area we have and there is a flow of charge. So I said there is a delta Q by delta T is here. Either what we can say, we can just write it Q by T. I is equals to what? Q by T. And you also know we can also apply the Q is equals to NE over here. So what is the I is here? I is NE by T, right? And you know what is the N is here, no? N is the number of charge carrier that is flowing through that particular cross-sectional area. If I am saying, if the current flow is not steady, right? What is the meaning of current flow is not steady? What is the meaning of steady? Steady means, like if I am saying 2 coulomb charge is passing through this area in 1 second, so for each and every time interval of 2 seconds, the same 2 coulombs should be passed through that, right? That is called steady flow. If the flow is not steady, then what will happen? Then we have to find out the current in a very short interval of time, right? That is called instantaneous current. What we will say over here, if there is a not any steady flow, then what we will say? We have to find current at a particular time interval or particular very small time interval. Very small time interval. Right. Very small time interval means what? Very small. It means delta will be replaced by d, as you know. So what we will say over here, the I is equals to limit delta t tends to 0, and this is what? Delta q by delta t. If delta t means time interval is very small, then what we can say is here, the I is equals to dq by dt. What is the I is here? I is equals to dq by dt. If I is equals to dq by dt, then this is called instantaneous current. This is called instantaneous current. Instantaneous current. Instantaneous current means what? When we are taking very small time interval, either in general what we can say at a particular time. Like I said, what is the current at 5 seconds? What is the current at 2 seconds? What is the current at 1 second? So these are called the particular time interval. So we will say it's the instantaneous current is there, right? Now let's see here. If I am saying these are the instantaneous current is here, and so next thing, if I am saying this is the conductor we have, this is the uniform conductor is here. So I said the I is here and I is here. For each and every cross-sectional area, what is the current is here? I. Because if the charge is delta q is entering over here in delta t time, so it will comes out with the same. There is not an issue, right? Now what I am saying, let's change the shape of this conductor. Now, if I am saying we are just changing the shape of the conductor. When we change the shape of the conductor, then what will happen? Like you can see, this is the shape of the conductor. Now what will happen with this? The current for each and every cross sectional will be different or same. That will be same. Why the current will be same? If I am saying there is a delta q is entering over here, then delta q will be comes out in same time, right? In same time interval, right? Why we are saying in same time interval? Because this is a conductor. This is what? This is a conductor. This is not a capacitor. If I am saying someone is holding the charge, it means it is a capacitor. But in this one you can see this is the conductor, only it's the simply wire we have. So wire is not a capacitor, so it cannot hold the charge. It means the charge entering over here is equal to the charge comes out over here. So for each and every cross-sectional area, what we will say, the current will be same. It means the I1, it means the I1 is equals to I2 is equals to what? I3. The current will be same over here, right? Now let's see here. If I am saying this is the area we have. One thing I want to ask you, this is the conductor we have. No? It's a simply a conductor we have. If this is the conductor and I said the current is flowing along this direction, so you know where is the electrons are flowing? What is the reality? Electrons are flowing. There is not any doubt, no? Because protons is inside the nucleus, as you know. If I am saying this is the conductor, then electrons is flowing over here. If electrons is flowing over here, so what I am asking to you, this is a charged or it's neutral? This conductor is charged or neutral? This is a neutral is here. What is this one? This is a neutral. Why this is a neutral? I am just writing over here. What we have to take from this one? We have to just write current carrying conductor is neutral. A current carrying conductor is what? Neutral. Why we are saying the current carrying conductor is neutral? Let's think about this. If I am saying this is the conductor we have, right? Sorry. This is a conductor we have. If this is the conductor we have, and initially there is no batteries connected with it, so this is a neutral or charge. It's neutral, like you can say any type of rod is there in your house, right? So that is a neutral. But what is happening when we connect with the potential source, like we are connecting with the battery? Now what will happen? The current starts flowing, right? So only the current is flowing now. If we are not connecting the battery, that is a neutral. After connecting the battery, the current starts flowing. So what is the use of battery? What is the battery? Battery is a source of energy. No? Battery is not a source of charge. What's the battery is providing to us? Battery is providing us energy. Due to that energy, the electrons start flowing, right? We cannot say that this conductor is charged. I will discuss about these things later, but you have to just understand a little bit here. No? Okay. Now let's see here. Let's see. If I am saying there is a two type of current we have done, that is delta Q by delta T. You know delta Q is for large time interval. No? And what is the instantaneous is here? We have done the instantaneous is what? It's the dq by dt is here, right? And we are saying it's a charge flow. Charge flow means not an electron flow, it's a charge flow. Any type of charge can flow, like we can say ions, holes, electron, anything can flow over here. So if I am saying there are some specific things how the current is flowing. If I am saying, let's see, if I said conductor, right? I said there is a conductor. So how the current is flowing in the conductor? Either we can say the vacuum tube, conductor, and what we can say there is a vacuum tube is there. So how the current is flowing in this one? The current is flowing in this one. There is a current due to flow of electron, right? In this one the current is flowing due to flow of electron. Now let's see the next. If I am saying, we are just taking the next. We can take, like I am saying electrolyte. Electrolyte. What we will say for electrolyte? In the case of electrolyte, there is a current. There is a current due to what? There is a flow of positive and negative ions. There is a flow of what? Positive and negative ions. Right? So next we have, this is electrolyte, right? What's the next we have to know? That is called semiconductor. The next one is what? Semiconductor. When we are saying semiconductor, so in the case of semiconductor, how we are obtaining the current? In the case of semiconductor, there are two things, right? The one is holes plus another is electron, right? Holes means what? Right now you have to understand, the holes means positive charge, right? You have to only understand this, right? In this chapter, this is our last chapter, no? That is basically we can say last chapter. So in that section we will study about more and more, right? Because this is very important section right now. Now let's see here. The next is called discharge tube. What is the next one? The next is discharge tube. What is the meaning of discharge tube? When we are saying discharge tube means in the case of this one there is a current due to flow of positive ions plus electron. Due to flow of positive ions plus electron. This is how we are obtaining the current in such type of substances, right? Conductor, electrolyte, semiconductor, and we can say discharge tube. In general they can ask with us, right? Now let's see here. Now we are just moving on the problems, no? Right? Because we have done the basic of all these things. Now let's see. If I am saying, I am just taking the basic problem over here. If this is a conductor we have, right? If this is the conductor and we are saying there is a lot of balls over here, a lot of balls over here, and we are saying there is a 3e charge on each ball, no? And there is the same lot of balls are here, and we are saying there is a 3e charge on each ball. Okay. Now what will happen over here? We are saying there is a boy. We can say you are here, right? It's a A, and there is the next boy. We can say B over here. The A is throwing 100 balls. A is throwing 100 balls per second, and B is throwing, we can say, the 50 balls per second, right? If this is throwing 50 ball and 100 ball, so we have to find out the magnitude of current and orientation of current, right? So let's see how we will find it out when we are dealing with the magnitude of current. So let's see, this one is sending 100 ball. So along this direction there is 100 balls. So what is the charge along this direction? Q1, the charge is 100 into 3e. We can say 300 E charge is flowing along that direction, and along this one what we can say, there is a 50. So 50 into 3e, that is Q2 is there, which is flowing along this direction. What is that one? 150 E is here. Okay. So what is the delta Q? What is the net charge? They are flowing in opposite direction, then we have to subtract it. Q1 minus Q2, that is equals to what? 150 E, right? So what is the current is here? The current is delta Q by delta T. So I is equals to what? Delta Q is what? Delta Q is 150 E by what is the time? 1 second. So what is the current is here? 150 E per second. And you know what is the meaning of E? E is what? E is equals to 1.6 into 10 to the power minus 19 coulomb. This is the value of E. Okay. Now let's move on the next problem, right? But before moving on next problem, I want to just tell you something about this one. The first thing, why we are studying this chapter, what is the need of this chapter, and what are the, is it compulsory that we need to understand all these things? Why we are studying delta Q by delta T? We can say there is a electrical energy is flowing. Why we are studying such type of things? Actually, if I am saying there is a flow, right? The flow is very important aspect for us. Any type of flow. What type of flow is there? Like if I am saying there is, in general I am taking, there is a water flow, right? I am just taking that one. Let's see here. If I am saying there is a tube we have, and it's a water tube is there, and I am saying there are ability that it can flows maximum 10 liter water per second, right? This is the capability of this one, 10 liter water per second. But when we will start flowing, I said just flow 12 liter water per second, 11 liter water per second. Is it possible to throw with this one? No, it's not possible. When you start just flowing such amount of water, I mean more than this quantity, then what will happen? It will be blast, right? So that's why the capacity is important. Because let's consider it. If we are saying like you are standing over here, right? If you are standing over here and we have just connected you with the earth, right? And your another hand we are just giving you shock. Let's see what type of shock I am just giving you. If I am saying we are just connecting you with this one. If we are just connecting you with the current in general, then what will happen? I said there are two situations, situation A and situation B. If I said there is a 1 coulomb charge flowing through you in 2 years, right? And in next one 1 coulomb charge is flowing through in 0.00001 second. What will happen with you? Can we say in this situation, if through you we are just flowing that 1 coulomb charge in 2 years, there is no effect on us, right? Why there is no effect on us? Because the current is very small. There is a very small quantity is flowing with us, so there is no any effect on us. But what will happen? If 1 coulomb in this, you can just imagine what is the value of current. So you will get a very heavy shock in this one, right? Because it's not our capacity that we can flow such type of current through our body, right? That's why we will get the shock from this. And you can see, like if I am saying there is a, in your household circuits there are a lot of type of wire is there. It's not like the every wire is same. there is some thin wire, some thick wire. Why there are some thin and thick wires are there? Because for each and every wire there are some different capability. Because if I am saying there is a thin wire and it's written on the wire, like I said, what is the capability of this one? 2 ampere. So you have to only flow maximum up to 2 ampere. It's not like you are just connected with the 3 ampere. Then what will happen, you know, right? It will be blast. That's why we need to understand what is the capability, how we can just flow the charge through any conductor. Because what is the main our thing why we are studying this one? Because we have to just transfer the electrical energy. And how we can transfer the electrical energy? It's a transfer the electrical energy with the help of transfer of charge, right? So how we can transfer the charge? With the help of potential difference and through any conductor, or we can through any discharge tube or whatever we are taking. So there is some limitations for that, right? That's why we are studying these things. If there is no limitation like this, so we can flow what type of, like we have to just flow the current, like I said, 11,000 ampere. Just connect a very thin wire and we will get the 11,000. It's good for us. But it's not possible that we can do such type of things. It will melt over here, no? Right? Why it will melt over here? Because this is not capacity of this wire that flow can such kind of current from it. Okay? Okay, so let's leave all this. Now let's move on to the next problem. Let's see. What is the next problem we have? I said it is given that the charge flow through any cross sectional area. So what we will see over here, let's see. It is given that this is the cross sectional area we have, and the charge is given as it's the 4t square plus 2t over here, right? This is the value of current through this, right? Now what I am asking to you, find the option A, average current in 0 to 5 second, and B, current at t equals to 2 seconds, right? So there are two things. One is what? Current in 0 to 5. Current in 0 to 5 means what? Average. If they are giving a large time interval, so there is the average. When they are giving the very small time interval, either a particular time like 2 seconds, so we have to find out the instantaneous. No? So what we will see over here, let's see. In this one, what is the value of current is here? If I am just taking the A over here. So what we know about the current? I is equals to what? Delta Q by delta T is here. What is the delta Q? We can say it's the Q final minus Q initial, and what is the delta T? 5 minus 0, right? So let's see here, what is the I is here. What is the Q final means what? Q at 5 minus Q at 0 by this is what? 5. What is the charge at 5 seconds? Let's put it's a function of time is there. Let's put the 5 over here. So what will happen over here when we put the 5? What is the result is here? It will becomes 4. I am just writing over here. When we are just writing over here, so it will becomes 525 into 4 is what? 100 plus. This is what? 2 into this one. It will be 10. And this is what divided by what? 5. So what is the result is here? Can we say the result is 110 by this is what? 5. 110 by 5. This is the value of current in ampere. You can cancel out, not an issue, right? This is the value of average current. Okay. Now what I am saying, let's find the value of current at 2 seconds. So this is the instantaneous current. So what is the instantaneous current is there? For B, what we have to do? For B, I instantaneous is what? It's a dq by dt. So let's differentiate it. So this is what? It's a ddt of 4t square plus 2t. So what is the differentiation is here? It will becomes 8t plus this is what? 2 is here. So current at 2 seconds. So I is equals to what? This is 16 plus this is 2. So what is this one? This is 18 ampere, right? This is the value of current at that moment. I is equals to what? 18 ampere. Okay. This is the one format that they can give you the Q and they can ask you about the I. Now let's see what is the next format that they can ask with us. They can give you the I, right? What they can give you, like they are just giving you I is equals to, I said I am just taking general, I is equals to 2t, right? Find the charge, find the charge flows through an area in 0 to 2 seconds. So how we will find out the charge flow over here? I is given, so I is equals to what? 2t. So I can be written as, we have to find the charge, no? So what we will say over here? I is what? In general, I is dq by dt is equals to what? 2t. Why I am just taking dq by dt? Because this is a function of time. So I is changing. When something is changing, then we have to find out instantaneous. And if they are asking for large interval, then we will find out the average in that. Okay, let's see here. What we can write over here? The dq is equals to 2t and this is what? dt. And this is the cross sectional area. Let's see. There is a charge is flowing through this. Okay. So at t equals to 0, I said the charge flow is q1, and at t equals to 2 seconds, we are saying what is the charge flow is here? q2. So what is the dq is here? Let's integrate it. So when we integrate it, we can say it's a what? q1 to q2, and this is what? 0 to 2. So what's the result? Integration dq is what? Q. And what is the limit is here? It's a q1 to q2, and take a constant outside. This is what? This is t square by 2, and what is the limit is here? 0 to. This is what? This is q2 minus q1. As you know, this is delta q. Delta q is equals to 2. 2 can cancel out with the 2, and 2 square is what? 4 minus 0. 0 lower limit. So what is the delta q is here? The delta q is equals to the 4 coulomb. This is the average charge flows in 0 to 2 seconds. Right? This is the second type. What's the next they can ask? The next type is they are asking the problems. Like let's see here. If I am saying, I am just summarizing this one, then you will understand. I is equals to what? I is equals to dq by dt. In general, I is what? dq by dt. Okay. If I is dq by dt, then what is the dq is there? dq is I dt. What is the dq is there? I dt. If dq is I dt, then let's integrate it. No? So when I will integrate it, then what will happen? This will becomes what? q1 to q2, and what is the time interval? t1 to t2. So q1 to q2 on integrating, can we say we will obtain delta q? What we will obtain? We will obtain delta q. So we will write it like the delta q is equals to what? Integration I dt, and this is what? t1 to t2. This is the value of delta q. Now you will understand why I have given this type of things. Because if I am saying, they are just saying like find the I average. So what we will say? And it is given that I as a function of time. Then what you will do in this one? Just write the delta q by delta t, right? But we know the formula. What is the I average is here? I average is delta q is what? Delta q is integration I dt upon time. Time is what? Integration dt. This is how we can find out the average in this. This is how we can find out the average current. Okay, I will just take one illustration on this one. Let's see. If I am saying it is given that I is equals to I naught plus alpha t. Find the average current. Find the average current in 0 to 2 seconds. Okay, we have to find the average current, and it is given that the I naught is 10 ampere and alpha is 4 ampere per second. The second will be cancelled out with the second, right? So let's see what we will do in this. Can we say in this situation what is happening? This is I naught and this is alpha. So let's see. I is equals to what? I mean I average is what? I average is what? I integration dt upon this is what? Integration dt. So I average is equals to integration. What is the time is here? 0 to 2. And what is the I is here? I is I naught plus alpha. It's a I naught plus alpha t, and this is what dt upon integration dt, right? Integration dt means total time. There is not any so in this one, right? So let's see what's the result is here. Can we say this is what? This is integration I naught. Can we integrate it separately? I naught is a constant. You can say it's a 10 ampere. So what we will say? This is 10 into what is the dt is here? T. Limit is what? 0 to 2 plus alpha is a constant, that is 4, and what is the integration of this one? T square by 2, and what is the limit is here? 0 to 2, right? And what is the total time interval is here? 2 seconds. Now you can just solve it. This is the I average we have. So what is the value of this I average? The value of this I average is, this is what? 10 into this is what? 2. So it will becomes 20, right? 20 plus this is what? Can we say 2 will be cancelled out with the 2, and 2 square is what? 2. So sorry, 2 square is 4. 4 into 2 is what? 8. 20 plus 8 by this is what? 2. So what is the I average is here? As you can see, it's a 28 by 2. So the I average is, it's a 14. No? 14 ampere. This is the value of current, right? They can ask you like this. If I am saying like, let's see, I am just giving you, the Q is given as Q naught sine omega t. Find the I. So what is the I is here? We know the I is equals to dq by dt. So what is the I is here? I is dq by dt. What is the dq by dt? It will becomes Q naught into, what is the differentiation of sine omega t? It's a cos omega t into differentiation of angle is what? Omega. So what is the I is here? I is Q naught into omega into this is what? Cos omega t, right? This is called alternating current, right? This is a type of alternating current we have. Okay, we will discuss about this later. There is a chapter that is called AC we have, right? Alternating current. Okay. So let's see our next topic, right? So next topic is current density, right? What is the meaning of current density, and why we are studying about the current density? Like if I am saying, let's see here. If I am saying this is the cross-sectional area we have, right? If this is the cross-sectional area we have, and we are saying there is a charges are passing over here, right? If the charges are passing over here, so we are just saying there is a current, right? So if there is a current, so I am just saying just observe from this side, right? If we will observe from this side, so what you will see? Can we say? You will see the current is just moving inside this loop, or we can say the area, right? So what we will say over here? This is the area we have, and what we are observing, like the radius is r over here, and the current is inside. Cross means what? Inside, right? If the current is inside over here, so I said the what is the net current? Net current is I. What is the meaning of net current? It means there is a di, right? So when we add all the di, it will becomes I, right? Like I am just saying, if we are just taking a small area over here, let's see. If I will take just a small area over here, then what will happen? This area is dA, very small area. So can we say the current is di, right? If we are taking any other area of same, then it is what? Di. This is what? Di. So what's the net current is here? Sum of all these things, right? So now let's see here, when we are just dealing with the current density, so what we have learned previously, the current is a scalar quantity, right? But if we all know there is a direction, right? For current there is a direction. So we have just taken the current density, it is a vector quantity, right? Which express the flow of current, right? What is the current density is here? It is defined as the current flow per unit area. How we define current flow per unit area? What is the meaning of this one? Like it is represented by Z. No? This is represented by Z, and it is defined as J is equals to I by A. J is equals to what? I by A. And this is a vector quantity. This is what? This is vector quantity. Vector quantity, right? If this is the vector quantity, so we are saying it's a vector along the current flow, right? So if we know the J at any point, so we can explain about the direction of flow of current, right? If I'm saying there is a area we have, right? If this is the area we have, and we are saying the same, the I current is flowing over here. I mean the net I current is here, right? If there is a net I current is here, so what is the J is here? Area is we are saying A. So J is I by A, right? So what we can write it over here? This is J is equals to, this is what? Can we write it n cap over here? What is the n cap is here? The meaning of n cap is it's a unit vector. This is what? This is unit vector along J, right? Along vector J. Like if I am saying this is the wire we have, let's see. If this is the wire we have, and I said at this moment the J is along this one, or we can say the n cap is along this one. So what we will see? The current at this moment is also along the same direction, right? So current is a scalar quantity, but we know there is a direction, right? But what's the problem? It's a scalar. So we have just taken a quantity which is vector. So with the help of which we can explain all the things related to the current, right? So that is what J equals to I by A. Now let's see here. If we are just writing it, so we can write it I is equals to what? I is equals to, this is J dot A. I is equals to what? J dot A. Okay? I equals to J dot A. And we know the A is what? A is a area vector. A is what? A is area vector. Like what I am saying. If I am saying this is the area we have, no? It may be possible. This is the area we have. Sorry, I am just redrawing it. This is the area we have. If this is the area we have, and we are saying at this moment this is the direction of area vector, and we are saying the current is flowing like this, right? If we are saying the current is flowing like this, so what we can say? This is the direction of J as well, right? If this is the direction of J, so can we say this angle is what? Theta. This angle is what? Theta. Angle between area vector and J. So what is the current is here? Can we say the current is I is equals to J dot A means what? JA cos theta. This is the value of current we have. So what is the current density is here? This is I by A cos theta. What is the current density? I by A cos theta. And what is the A cos theta is here? A cos theta is the component of area along Z. Component of area along Z. Either what we can say? A cos theta is the component of area which is perpendicular to the current flow, right? Like I am just telling you, let's see. Here is the space we have. Like if I am saying, this is the, how you know about the component, let's see. If I am saying this is the area we have, right? And we are saying the area is a vector quantity. So can we say this is the vector A we have, right? And what's the angle is here? This angle is theta. If this angle is theta, so what we will say over here, can we take the component of A? So this is what? This is A cos theta, and what was this one? A sin theta, right? So what do you understand with area of this, right? It means this is the component of area along this. This is A cos theta, and here is the another component we have, which is A sin theta, right? So current is flowing along this direction. So which way area we have taken? We have taken this area. That is what? A cos theta. So what is the formula of J? J is equals to I by A cos theta, right? Now let's see here. If I am saying it is given that at any point area is A equals to 2i cap plus 4j cap and minus k cap, and the j is given as I cap minus j cap plus 4k cap, right? So what we have to find over here, we have to find out the current in this. So what is the current? Current is J dot A. So we have to take the dot product of this one. So what is the dot product is here? I is equals to, just take I dot I is what? 2. J dot J is what? It's a minus 4, right? And K dot K is what? It's a minus 4. So what is the I is here? Sorry. I is J dot A, it will be 2 minus 4 minus 4. So I is equals to what? Minus 6. Right? I hope you understand the meaning of minus. It's in reverse direction. Right. Now let's see here. It is not only confined up to this limit. Right. Let's try to just understand better about this one. If I'm seeing this is the wire we have, right? If this is the wire we have and this is the cross-sectional area, right? This is the cross-sectional area we have, and we are saying this area is A1 and this area is what? A2, and the current in this one is what? I1, and current is coming out is what? I2. So I want to ask you one thing. I1 and I2 are same or not? I1 I2 are same. Why? Why the I1 I2 are same? Because this is a conductor. This is what? This is a conductor we have. What's the nature of conductor? It can flow the charge, no? Right? Because there is a path available over here. So the charge will flow from this. It's not possible that if I am saying the 2 coulomb charge is enter over here and the charge coming out is 1 coulomb. It's not possible. Why? Because it's a conductor, it's not capacitor. In the case of capacitor, there is an ability to hold the charge. But this is the conductor. No? In this, it's not possible that it will hold the charge. It will pass all the charge which is just coming from this surface, right? So what we will say over here, we can say at this moment the I1 is equals to what? I2. And what we can say about J1? What is I1? Can we say I1 is J1 dot A1 is equals to what? J2 a dot this is what? A2. Can you just imagine it is look like familiar to us, right? Where we have learned such type of things. We have learned in fluid mechanics in class 11th. What we have learned there? A1 V1 is equals to what? A2 V2. That is called equation of continuity. So if in this one we are saying the current is flowing from this conductor, then this is called equation of continuity. This is what? Equation of continuity. This is equation of continuity, and you can also just write it directly like J1 A1 is equals to what? J2 and A2, right? Because in this one you can observe both have same direction, so the theta will be 0 degree and cos theta is what? 1, right? Now let's see here. Let's try to see some illustration based on this. Okay. At this moment, one thing is also at which the J is more, you know, I by A. So if we are saying at this moment we have a J1 and at this moment we are saying we have a J2, so we can say the J1 is less than what? J2. J1 is less than J2, right? Now let's see. If I am saying this is the area we have, right? I said what is the radius of this one? The radius of this one is R and the I current is flowing inside. I hope you can imagine this conductor. No? Its conductor, cylindrical conductor is here and the current is moving inside. I said the total current is what? I. So what is the J is here? J is equals to what? I by A. A is what? Pi R square, right? So what do you understand with the meaning of this one? The meaning of this one is this is the current. This is the current in unit area. This is what? This is current in unit area. Because if I will ask you now, for this one, we have taken only this area. From the same, if I am saying We have taken only this area, that is R by 2 over here. Now I will ask you, what is the current in this region? It's a part of this one, right? So what you will say right now? You will say the current in this one is I dash is equals to, what is the current in unit area? J. And what is the area is here? It's a pi R square by 4. So what is the current is here? The current is equals to the I by 4. So current in this segment is what? I by 4. This is very useful in the case of when we start the magnetism, right? Here this is also useful, let's see it. But main use is in the case of magnetism. If I am saying, let's see, I am just taking the next illustration for this one. If I am saying there is a area we have, no? It's the same like I am saying this is the area, or you can say it's a cylindrical conductor we have. The current is flowing like this. Okay. So I am just taking the view of this one from the bottom. No? So let's see here. This is a conductor we have, right? If this is the conductor we have and we are saying the radius of this one is what? R. Radius of this one is R, but the J is given as J is equals to C into R. J is what? C into R. What is the R is here? R is a separation of the point from the center, right? Separation of the point from the center. Actually, what's the problem in this one? Previously what we have done, in this one J is a constant value. Why J is a constant value? Because there is a uniform distribution, right? So in the case of uniform distribution there is no problem at all, right? But in this one you can see what we have. In this one the J is variable, J is varying with respect to R. Because when we are at the center, R is 0, J is 0. But when we are at the surface, so R is capital R, so J is what? CR, right? So let's see how we will find the current in this one. What we have to find? We have to find the current in this one. So let's see how we will find out the value of current in this one, right? If I am saying this is a same conductor is here, right? And this is the total radius R. In this one, as you know, if the things are variable for us, like we have done in the case of that electrostatics, so what we have to do? We have to take an element. So I am just taking, let's take an element over here. I am just taking an element over here and I said, what is the radius of this one? R, right? If radius of this one is R and I am saying let's take the thickness of this one is also. Thickness of this one is R. Thickness of this one is, we can say dr. What is the thickness is here? Dr. So in this one there is also current is flowing everywhere. So we are saying there is a current in this region, only in this area, right? Very small area is here. So can we find what is the value of this elemental current? Can we find it out? Let's see it. If we have to find out the current, and one thing is also, if dr is very small, we have taken very small element. So when dr is very small, so can we say J is constant? Like what I said, R is what? R is, let's assume the R is 1 meter, right? So what is the J is here? J is C into 1. It's a C, right? And I said, if we are saying dr is what? Dr is 0.00000001 meter, right? So what we will write over here for this? J is C into 1 plus 0.00000001 meter. Can we say it's a nearly negligible for us, right? So what we will say in this situation? In this situation it is same, right? So when the change is either we are saying that we are taking the very small element, then what is happening? The variable will becomes constant, right? Like we have done in the class 11th also. So what will happen over? Let's cut it and just do it flat, no? So this is the area we have. If this is the area we have and there is a current flowing inside, and what is the thickness of this one? Dr. And what is the total length is here? 2 pi r. So what is the current in this region? Current is what? Current is J into A. This is the current. So this is Di is equals to J is what? C into R into area. What is the area for this one? Area is 2 pi r into dr. Why we are saying it's a 2 pi r into dr? Because this is length is 2 pi r and this is what? Dr is here. This is the area of this element over here. So this is di. If we have to find out the I net, then what we have to do? Can we integrate it directly? Current is a scalar quantity, right? So when we integrate it, then what's the result we have? The I net is equals to, this is what? CR into 2 pi R dr, where the R is changing from 0 to capital R. There is a surface boundary we have. So what is the I net is here? The I net in this situation is equals to, take a constant outside, so we can say 2 pi C will be outside, and this is integration 0 to R square, and this will becomes dr. So what we know about the integration of this one, it will becomes the 2 pi C, and this is what? R to the power 3 by 3, because when you put the lower limit 0, no, it will become 0, right? This is the result we have. Okay, now I am just giving you one homework. I hope you will do it. No, let's see a homework over here. If I say the J is given as J is equals to AX square, right? This is the J we have given over here, and let's see what is the meaning of X over here. This is a wire we have. No? Don't assume it X, Y, Z. I am just taking only for reference over here. This is the wire, and in this one, the current is flowing inside, right? And this is the current density. The radius of this one is R0, right? And there is a one thing is also, just a minute. There is another reason in this. In this reason, this is R0 is here, and the inner radius is R0 by 2. Inner radius is what? R0 by 2. I am just redrawing it. Just a minute. This is the outer part we have, and this is a inner radius we have. What is the inner radius is here? That is R0 by 2, and here is the current we have. So you have to find out the total current. It's a cylindrical wire, you can imagine. It's a cylindrical wire. So you have to find out the I net in this situation, right? Okay, let's start our next topic, right? So what's our next topic? The next topic is drift and drift velocity, right? So first we need to understand what is the drift and why we are just discussing about all these things. What's the reality is here? It's all is basis on the assumption, or we can say what's the experiment we have done. That's what we are just taking the assumptions from all the experiments, right? So let's hear what we have assumed over here. I am just taking some basics of conductor, right? If I am saying this is the any type of conductor we have, I will just take the spherical, then it will be very good for us, right? Let's see. This is the conductor we have. If I am saying this is the conductor we have, and we have applied the external electric field, okay? So when we have applied the external electric field, then what will happen? What we have done in electrostatics, can we say the minus is accumulated over here, due to which there is a plus is here, right? If there is a plus over here, then what will happen? Can we say if we are taking any point, like I am just taking the point P over here, so at point P what will happen? At point P there is a electric field what we have applied. I am saying E external, right? And there is also the charges are accumulated over here. So due to this charges there is another electric field is here, right? So this is the induced electric field. This is what? This is a induced electric field we have. If this is the induced electric field we have, and when I am saying this is the conductor, what I am saying, this is a conductor. So when this is the conductor, so in the conductor, the net electric field is what? 0. Why the net electric field is 0? Because in this one, the E induced is equals to the E external. Actually, how the charges are induced over here, what is happening in all this situation, we have learned in the class electrostatics, right? So now let's see. If I am saying, when we are saying this is the any conductor we have, right? Let's see. If I am saying this is any conductor we have. If this is any conductor, then we all know there is a positive fixed ions are there. As you know, there is a free electrons are also here. I am just taking some of ions only. These are the ions, we can say fixed ions over here, right? If these are the fixed ions over here, and there are free electrons we have also, right? Then what is happening in general? In general, there is electron is available over here and that is free. So due to thermal agitation, what is happening? The electron is moving in this, right? The electron is moving in this one like this. This is how we can say the electron is performing zigzag motion in this one, right? If the electron is performing zigzag motion in this one, so we can see the net displacement is zero. Net displacement of electron is zero. Okay. If the net displacement of electron is zero, so we are saying there is no current, right? There is no current in this, because we all know if there is a from any cross-sectional area, if charges are crossing over there, so we are saying there is a current. Because in this one, what is happening? I am just taking some more about this one. Let's see here. If I am saying, let's assume this is a. I am just taking the simple thing like let's assume this is a your room is here or whatever you can assume. Our hall is here, right? And you are standing over here, right? And I am saying there is a your identical persons over here. No? A lot of you are observing. There is a lot of people, and everyone is look like same. Okay. If everyone is look like same, that's what we can say the electron is here, right? So what will happen? If I am saying this is the cross-sectional area is here, right? If this is the cross-sectional area is here, then what will happen? Let's assume this man is crosses to this area from this side, right? Then what will happen? Another will be here, right? Any other will be just over here, and when it is moving over here, so can we say there is another is crossing over here, right? Because the space is same. So when I am saying this person and this person is same, so what we will observe, like I am saying this is identical, ऐसे समझ लो पूरा identical है. अगर ये पूरा identical है, so when this person is displacing towards right and this one is displacing towards left, so what we will observe? We will observe nothing, because we will observe the zero displacement. Because like this is electron, it will comes over there and it will comes over here. So it's the same situation. The charge flowing towards left is equals to charge flowing towards right. So that's why the net charge is what? Zero. That's why there is no current in this one. Same thing is happening with conductor. The electron is here and not a single electron. A lot of electrons are there and they are performing zigzag motion. And why they are performing motion? They are performing, I am just writing over here. The electrons are, I mean the free electrons. The free electrons are performing zigzag motion due to thermal agitation, right? Thermal agitation. They are performing zigzag motion due to thermal agitation, and there is a collision with the fixed ions over there, right? That's why they are performing zigzag. But what is the net displacement? Zero. That's why the current is zero. Now let's think here. If I am saying there is a thermal agitation and due to which this is happening over here, so there are some terms that we need to understand, right? There are some terms related to this, like we can say there is one term that is called mean free path and relaxation time. What are the terms? Mean free path and relaxation time. What is the meaning of mean free path and relaxation time? Like in this one, what is happening? The electron is starting from here, right? It collide with this one, again it collide with this one, again it collide with this one. So what is happening? Between two successive collision, the electron is free. No? When there is an electron field, it's bounded. When there is a collision with the object, because like just assume I am an electron and I am just moving along this direction, then what will happen? There is a wall we have, right? So when I will move over there, then I will collide with the wall. So it means wall is just exerting the opposing force, right? And that opposing force is very high. We can say it's exponentially is there, right? But we don't have to consider exponentially. We will take some part only that, right? So let's see here. When I am right now, let's assume from this wall, I am just started from this wall and again I have collided with that wall. It means between these two walls I am free now, or you can say I am in relaxed mode, right? Because there is no any collision. So between two successive collision, what's the distance I have covered? That is called free path. That is what? Free path. So what is the meaning of free path? It's the distance traveled by particle between two successive collisions. That is called free path, right? Because the electron is free in that. What's the next we have? The next is called relaxation time. What is the meaning of relaxation time? It means for what time the electron is relaxed. It means between two successive collision electron is rest, right? So the time taken, or we can say the time interval between two successive collision is called relaxation time, right? क्या बोलते हैं उसे? Relaxation time. तो देखिए यहाँ पे मान लो हमने आपसे बोला कि in this one, like I am just only taking the motion of electron. So let's see. If I am saying it is starting from here, moving at this point, again moving at this point, again moving at this point, again moving at this point. So what we will say? In this one it will travel a distance s1. In this one it is travel s2. In this one s3. In this one s4. I am not saying it cannot travel the same. It can travel the same, right? But it can also travel the difference. That's why we are just taking the different over here. And also it is taking the time t1 over here, t2 over here, t3 over here, t4 over here. So what we will say in this one? What is the lambda? Lambda is called mean free path. This is what? Mean free path. What I said about mean free path? Mean free path means it's a mean of all the free paths. Simply you can say it's an average, right? So what we will say over here? The lambda is equals to average is what? S1 plus S2 plus S3 plus dot 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 Sn by n. This is called lambda. That is called mean free path, right? This is a lambda we have. Okay. Now let's see the next thing. The next is called relaxation time. So similarly, this is called mean free path, and the next is we have this is relaxation time. Okay. So what is the meaning of relaxation time? The relaxation time is it's a time interval between two successive collisions. So when we are just finding the relaxation time, it is represented by tau. Tau is same t1, t2, t3 dot dot tn by n. This is the average of all the time interval. This is called relaxation time, right? Now let's see here. So these are the basic things like what is happening before we obtaining the current. This is initial situation. If we have any conductor, like you can say there is a iron rod in your home, so it's the same thing is happening in that, right? And the net current is 0. Now let's see here. What's the next will happen with us? If I am saying now we will apply the external electric field. So what will happen with the conductor? Like if I am saying this is the conductor we have, right? And we have applied the external electric field. Then what will happen? You know about this one. What will happen? There is a minus charge is accumulated over here, and there is a plus charge is accumulated over here. Why they are accumulating over here? Because if on minus there is a force is acting opposite direction, on plus along this direction. But it's not possible in general. In general, it's not possible that electron will extract from the metal, right? So what will happen over here in this one? They are trying to move outside, but they cannot move outside the surface boundary. No? There is a surface boundary of this conductor, so they cannot move outside. There is force is acting, but they cannot move outside because there is no path is available. Okay. So in this one, what we will say, the net electric field is 0. Sorry. In this one, what we will say, the net electric field is what? 0, right? Net electric field is 0. So what we can say over here? Now we have to obtain the current. So what we will say over here? We are connecting the conductor with the wire over here, right? So when we connect the conductor with the wire, and in general I am saying we are connecting with the battery. Now what will happen in this one? Can we see there is the external electric field is applied over here? So same, there is a minus charge are coming over here, but what will happen? Due to this electric field, there is a path we have applied the battery over here, so there is a path. So can we say that will move over here? The charges will move over here. If charges will move over here, so you know if there is a flow of charge, so we can say there is a flow of current we have. There is what? There is a flow of current we have in this situation. This is how we are obtaining the current. But now let's see. If I am saying before this one, what we have done, the electrons are performing zigzag motion like this. So can we say there is some speed? भाई इलेक्ट्रॉन, अगर इलेक्ट्रॉन ऐसे चल रहा है तो स्पीड तो है उसके पास. So what we can say about this speed of electron? The speed of electron is nearly, in this one, speed is nearly in the order of 10 to the power 5 meter per second, 10 to the power 4 or 10 to the power 5 meter per second. This is the order of speed of electron, right? If this is the order of speed of electron, but what is the average, what is the displacement? Zero. But when the displacement is zero, no? So what is the velocity? The average initial velocity is what? Zero. Because the displacement is zero, right? And one thing is also, do you understand what I said, how the displacement is zero? It's not like that this electron will return to its original position. It's not like it will be happen always. It may happen, but it's not sure it will happen, right? So what is happening over here? This electron is moving, like I said, this is moving along this direction. So there is another electron which will comes at same point. So that's why we are saying the net displacement is zero. So we say the U average is what? Zero. This is the velocity we have, right? So what is the average initial velocity? That is zero. And what is the speed is here? This is speed. This is the order of speed we have. This is not the order of velocity. The velocity is zero. Now let's see here. So in this one what I said, when we have applied the external electric field, then what is happening with the charged particle? I hope you understand this one, so I am erasing this now. Let's see. Let's see. If I am saying there is a, I am just only drawing the conductor now. This is the conductor we have, okay, and what we are saying, there is a lot of, I am just taking a single electron, there is a lot of collision for us, right? There is a lot of collision over here. But what I am saying, when we apply the external electric field along this side, okay, then if we apply the external electric field, then this is the electron we have. So can we say there is a force acting in opposite direction? What is the force on electron? The force on electron is what? F is equals to EE. What is the force on electron? F equals to EE. This is the force acting on the electron. If this one is the force acting on the electron, then what is the acceleration is there? Acceleration is EE by M. This is the acceleration acting on electron. But if on this electron there is a acceleration is acting, because before what is happening, there is no any external acceleration is acting like this. That's why we are saying that net displacement is zero. But in this one what will happen? When there is a force is acting, then it will shift it, slightly shifted over here. And how this is shifted over here? Due to the external electric field, right? Let's see what is happening. If I am saying this is the electron we have, right? And there is an external force is acting over here, that is due to electric field. So it is just traveling like this. Let's assume it is traveling like this. But when it has to come at this moment now, but it will be slightly in forward direction from that. Very slightly in forward direction. Why this is very slightly in forward direction? Due to this force over here, right? Because if force is acting over here, so it will be shifted. And now you can see there is a slightly displacement is here. If there is a slightly displacement is here, so can we say now the displacement is non-zero? And when the displacement is non-zero, it means there is a force. It means what we will say? There is a force is acting on this. And if there is a force acting, displacement is here, so can we say there is a velocity, right? And when there is a velocity, also we can see this electron or the charge is crosses this area, right? When it is crosses this area, then we can say there is a current. Then what we can say? There is a current in this one because the electron crosses the area. When it previously it is also crosses the area, but in this one what is happening? There is a shift, right? Because in this direction this can only shift the particle along, I mean the electron along this direction. It's not like it will shift the one electron along this direction and another electron along this direction. It's not possible, no? Because the force acting on the electron is opposite to the electric field. So it will shift all the charges in same direction. Okay. So now let's see here. This is the acceleration acting on this one. What is the average initial velocity? Zero, right? Okay. And one thing is here. If I am saying due to this acceleration, it is slightly shifted over here. So this is displacement over here. And this displacement is called drift. This displacement is called what? Drift. right? I'm just recalling you one thing, like you have done in the case of class 11th, right? What you have done, there is a topic that is called relative motion. So there is a river boat problem and a lot of things are there, right? So it's the same thing is there. What is the meaning of drift? Like we are just standing on any platform and the platform is shifting over there. And when the platform is shifting, so due to that platform we are also shifting. That is called drift, right? So in this one same thing is happening. There is an external, we have applied external electric field, and due to this external electric field the electrons are shifted over here. Either we can say electrons are drift over here, right? So if there is a drift over here, or we can say displacement over here, so due to this displacement there is a velocity. That velocity is called drift velocity. That velocity is what? Drift velocity. So let's see how we will find out that. What is the U average initial? 0. I am just writing the velocity of the charged particle over here. So we know the V is equals to what? U, I am just taking average. U plus AT. We all are familiar with this, right? So what we can write over here? This one is 0, right? And if this is 0, so can we say V and U are in same direction? So there is not an issue to take the vector, you can solve without vector, right? So what is the V average is here? V average is equals to, this one is 0, AT, right? What is the A is here? A is E by M into this one is what? T. But you can say this is what? This is for, sorry, this is T. And this is for what? This is for a single collision, right? But there is a lot of collision is happening over here. So we have to take average for all the collision, right? So what we will say over here, when we are taking the average for all the collisions, so what will happen? The V average is equals to what? It's a V1 average, V2 average, V3 average, V4 average, dot, Vn average. And one thing is also, it's not the velocity of different particle, I mean 1, 2, 3. It's the average velocity in different collision. First collision, second collision, third collision is there, right? And this is divided by n. So what we will say over here? The average velocity is equals to what? V is equals to what? U plus AT. And you know when we are taking the U1 plus U2 plus U3 dot UN, by this is what? N plus AT. So it will be A into T. And what's the about T1? T1 plus T2, because A is same, T3 dot Tn. By this is what? N we have, right? For multiple collisions are there. So what we will say about the average velocity? This is, I am just removing vector because it's the same direction. No? So this is 0. So V is what? A into, this is what? Tau. I have already done with this one. No? This is what? Tau. So this is the average velocity. And this average velocity is A. A is what? E into E tau by M. This is the value of average velocity. And this average velocity is called drift velocity. This is what? This is called drift velocity. This is called drift velocity, right? And this drift velocity is a constant velocity. This is what? We are assuming it's a constant velocity. What is the meaning of constant velocity? Like we are saying, this is a conductor we have, and I just said initially, it's only assumption is here. No? So this is the electron is here, no? It's assumption. All the electron is moving with Vd. All the electron is moving with what? Vd. All the electron. If there is an electron in this one, so they all are moving with Vd velocity when we apply the external electric field, right? So this is the EVM. There is another idea also about this one, right? So what is the another idea about this one? Let's see. What's the another idea is here? Let's see over here. First I am just writing the Vd over here. The Vd is what? Vd is EE by M into tau. So simply we can say Vd depends upon electric field as well as tau, because E and M is constant. A is the charge on electron, that is 1.610 to the power minus 19 coulomb, and the M is the mass of electron, that is fixed 9.110 to the power minus 31 kg, right? Okay, so just copy this one, then I will come on the next one. What's the next idea about this terminal velocity or drift velocity? Okay, so Vd is equals to what? EEM by tau, right? Let's see here. Actually, you know the fluid mechanics, right? I am just slightly taking this one, fluid mechanics, only that you can understand this one. What is the meaning of terminal velocity? In the fluid mechanics, what we know about the terminal velocity, like if this is the conductor we have, this is the container we have, and in this container there is a fluid we have, right? If there is a fluid we have, then what we know? We know if any ball, that is called Stokes law, I hope you all know, right? If I am saying there is any ball we have, no? This is the very small ball we have, and this ball start moving in this fluid. So what we know? The mc is acting in downward direction, buoyancy is acting in upward direction. Also, there is a air drag, that is Stokes law, no? That is 6 pi eta rv. I hope do you have remember this one, right? So when we are saying initially, when any ball is just immersed into the water, then what is happening? Initially that is moving in very high speed. Like जैसे मान लो अगर कभी तुमने jump लिया हो तो पहले बहुत तेजी से नीचे जाते हैं. But there is a air drag as well as buoyancy is there. That's why due to this forces the velocity decreases. And when the velocity decreases, so you can see there will be a time this force is velocity dependent. When this force is velocity dependent, then what will happen? They will balance the mc, right? What they will do? They will balance the mc. And when they will balance the mc, then what will happen? The net force will be 0. And if the net force will be 0, then this is moving with constant velocity. This is moving with what? Constant velocity. If this is moving with constant velocity, then this velocity is called Vt, or we can say this is called terminal velocity. What is called? This is called terminal velocity we have, right? Now let's see here, it's the same, just assume inside the conductor. If I am saying there is a conductor we have, if this is the conductor we have, so in this conductor what is happening? This is the conductor we have, and in this one, if I am saying there is an electron, right? Let's just think about the electron is here. We have applied the external electric field E. Okay, then what is happening? There is a force acting along this direction, that is what? E into E. There is not a doubt. What is the electrostatic force? It's a Q into E. We all are familiar with that. Now let's see here. There is an electron. That's why I have taken the E. अब मान लो अगर हमने आपसे बोला कि when the electron start moving in this side, then what will happen? There is a collision, right? And when electrons start moving on this side and there is a collision, so this is the opposing force, right? Due to this opposing force, the velocity will be decreases. So one is increasing the velocity, another is decreasing the velocity. So what we will assume for electron? We will assume for electron, it's only assumption, what I said initially. What will happen over here, in this one, there is a opposing force is acting along this direction. There is a opposing force is acting along this direction. So due to this force, the velocity will be reduces. So what we are assuming, when these two forces will be equal, then what will happen? The electrons will move with the constant velocity. Electron will move with the constant velocity, and that is called Vd, or we can say drift velocity, right? This is what? Drift velocity. And this drift velocity is basically, we can say this is also, we can say it's a terminal velocity. This is what? This is a terminal velocity for us, right? It's a constant term, right? So when this is the constant over here, so let's see, this is a electron we have, there is a E is acting along this side, and the opposing force is here. In reality, the opposing force, that is proportional to the velocity, and there is some exponential term is also. But in this one, we are not taking the exponential term, we are just taking only some ideal situation, right? So in ideal situation, what will happen? The force is proportional to the velocity, right? It's a minus v, but I'm just writing the magnitude over here. So we can say this opposing force is equals to c into v. C is any constant is there, right? So what we will say in this one, when there is a terminal velocity, so these things should be equal. So what we will say, what is the net force is here? The net force is E minus CV, because they are in opposite direction, that is 0. So what we will say over here, can we say the CV is equals to what? E into E, right? So V is equals to E by C into E. This is, and this velocity is what? Drift velocity, right? I hope this one is very easier for you to understand, because there is a positive ions over here, so they are exerting the force, so we can just assume there is a fluid, right? Just assume they are exerting the force like fluid and an electron is moving inside the fluid. So this is the situation over here, and this constant velocity is called Vd, drift velocity. Okay. Now let's just think about this one. If this is the drift velocity is here, so what we will say about the Vd? The Vd is equals to the E by C into E. This is Vd. And if we are just coming on this constant C, then we can see the C is equals to what? It's a nearly, we can say it's a m by tau. This is what? M by tau. If this is m by tau over here, so what is the Vd is here? The Vd is equals to EE by m into tau. You can just observe it's the same thing, right? Okay. So this is the Vd we have. Now let's see the next thing. What I want to tell you. Let's come from this one. When we are just coming from this one, then this is Vd and that is equals to E by C into E, right? So what is the E by C? E by C is Vd by E. Vd is what? Drift velocity, and E by C is what? We are saying E is the charge on electron and C is that constant. And it's a dependent constant. It's not like it's an independent constant. Like we know in Stokes' law, F equals to 6 pi eta Rv. So that forces depends upon eta. If we are changing the conditions medium, then the eta will be changes. So same thing is here with the C, right? If this is the C is here, then this term is called mu. This term is called mu. Mu is equals to the Vd by E. Mu is what? Vd by E, and this mu is called mobility. This is what? This is called mobility. You know the meaning of mobility? Mobility means it say about how the particle is moving in the fluid, or we can say how the electron is moving in the conductor. If I am saying we have a very good conductor, then what will happen? The mobility will be very high, and mobility also depends upon mass. I will just explain you. It's here. This is mobility we have, but mobility is Vd by E. But this mobility does not depends upon Vd and E. It does not depends upon Vd and E. If we have to define mobility, so how we can define it? We can say in words like mu is equals to the drift velocity at unit application of electric field. Unit application of electric field. What is the meaning of this one? When we are saying the E is equals to 1, then what is the mu is here? The mu is Vd, right? But it does not depend upon we can say E and Vd, like V equals to IR. But R does not depend upon V and I because that is a constant, right? Now let's see here. In this one, the mu depends upon temperature and pressure. Mu depends upon what? Temperature and pressure. It depends upon temperature and pressure. Now I am just taking this one, then you will understand. What is the mu is here? I said the mobility is E by C, right? So what is the mu is here? E by C is what? M by tau. This is here, right? M by tau. If this is the mu we have, like we know that I have just written over here. What is the C is here? The C is M by tau over here, right? So mu is E by M into tau. So you can observe simply, either you can just write it directly. The mu is proportional to 1 by M. Mu is proportional to what? 1 by M. It means the mobility is proportional to 1 by M, or we can say the mobility is inversely proportional to the mass. What is the meaning of this one? In general, you can take in general, if I am saying there is a very heavy man, right? If there is a heavy man, जैसे मान लो कोई बहुत मोटा आदमी है, तो क्या उसकी मोबिलिटी कम होगी? क्योंकि उसको ट्रैवल करने में टाइम लगेगा, प्रॉब्लम है उसके साथ. But अगर कोई पतला है, फ्री है, so that can easily movable, right? So when we are just discussing about this mobility, then mass matters a lot, because when this is inversely proportional to mass. When the mass is high, then mobility is what? Is small. This is very important concept we have, right? We will again discuss about this one in the case of semiconductor. Right? We will discuss about this one in which chapter? Semiconductor. There are two things, hole and electron. So we are assuming the mass of hole is more as compared to the mass of electron. That's why the mobility of hole is less as compared to electron. And one thing is also, if mobility is small, so we will say the current is also small due to that one. If mobility is small, right? Okay. So this is all things that we have done related to the drift velocity and the drift, right? So what we have just concluded from this one, this is the formula for VD we have. In general, what's the formula we have taken? This one, right? This is the formula that we have to remember. I am just writing over here. Let's see. What is the drift velocity that we have to remember? From today we have to remember it's a E by m into tau, and this is it depends upon E as well as tau, and tau depends upon temperature, right? Now let's see here, and what I said, the mu is what? The mu is Vd by E. Either one thing is important from this, the mu is proportional to 1 by m. जिसका mass ज़्यादा उसकी mobility कम, right? Okay. So this is what we have done for the day. In the next lecture, what I will start? In the next lecture, I will start. There is a concept that is called the relation between drift velocity, current density, as well as the current, right? So in the next lecture, we will start Ohm's law and relation between drift velocity, current, and current density. Okay? Okay. Bye bye.